Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendra Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra, a dynamic mathematics software, is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing a worksheet to visualize a sphere. For preparing this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let us try to visualize what type of worksheet we will be showing to the children. We will first fix the radius. Then we will define a sphere. It is a set of all points that are equidistant from a common point in a three-dimensional space, and we will try to draw the sphere and tell the surface area, and we will tell the volume, and we can tell the volume, and we can show the volume also. Okay, now the child can come and visualize it by rotating it and then seeing it how the sphere looks like, and by changing the radius they can get the values of surface area and volume. Okay, let us try to design this dynamic worksheet from scratch. Okay, for that I have taken GeoGebra Classic 5 worksheet, geometry view, and in option rounding off to 1 decimal place and labeling of new points only. Let me start the three-dimensional view also. In the 3D graphics, normally we will remove all of them, but here we will remove only the plane. Let us keep this axis as it is. Okay, now let us go for the heading. You can go for a heading. Sphere. You can define the sphere also. Okay, the sphere is already defined in the worksheet which I told you. Now this can be copied because I have only one thing to be copied. For I will copy it and I will paste it over there. You can type it also, there is no issue. Okay, you can tell the children that what is a sphere. Okay, the sphere is set of all points that are equidistant from a common point. Okay, now I am showing it clear. Okay, now this one will have a radius, therefore click on the graphics. We have 2 dimension. Remember, only in 2D graphics you are having the slider, therefore you have to have the graphics view also. Go to the slider. Okay, let us put it. Let us call the slider as radius. Okay, now let us have the radius from 1 to 10 with increment 1. You can have the increment as per your convenience. Okay, now radius I have kept it. Come back to the 3D graphics. Escape, always finish it. Okay, now go for a point and then you can fix the point at the origin. The origin I am just taking it as A. Now I am going to design that sphere now. You see, go back to this 3D graphics and the tools are open now. In the sphere there are 2 ways of getting center and point, center and radius. Here the point, if you are just already having it in any of the axes, you have to touch the center and touch the point only. Now here I have a control over the radius, therefore I will take the second one, center and radius. Simply touch it, it will ask the radius. Now what is the radius now? It is the variable radius which I have fixed. Therefore I am keeping this okay. And now you got it now. Now I have not removed this axis only to show a clear picture about the sphere. Suppose if you remove this, for example in the 3D graphics, if you remove the axis, you see it doesn't look like a sphere. Okay, therefore if the axes are there, sometime a feel of the sphere is coming, therefore a child can understand. Now I have taken it centered at the origin, therefore it will be x square plus y square plus z square is equal to r square. Highly interesting, because the child know that x square plus y square is equal to r square. Now it is x square plus y square plus z square is equal to r square. Okay, well, now let us try to visualize the surface area and all very quickly. Therefore you can tell the children that what is surface area. Okay, I think everything is depend on the radius only. Therefore, surface area is equal to 4 into, in the symbol you can go for this multiplication, pi, again you can go for the simple multiplication, radius square, radius the whole square, or you can go to the symbol and you can have the basic and the symbol square. For a child, you can understand the formula, surface area is equal to 4 pi r square. Now go to this view, go to this input bar. Now what you can do, now you can have the volume also. Now volume is equal to, surface area, yes, S is equal to 4, okay, star, multiplied by 22 by 7, okay, multiplied by the radius, the whole square. For the square, go to this alpha, in that alpha select this square. You got it now? 4 pi r square. You can enter it now. Okay, now if you want to show the children that what is the surface area, you can have now SURFACE, surface area is equal to, now just now I have made it as capital S, therefore it is capital S. Okay, now this capital S will come over here. Okay, now suppose if the radius becomes 7, all of you know that it will become a whole number as 616, because as I have taken pi as 22 by 7. If you take pi directly as pi in this formula, then it will take it as 3.1415. Accordingly, it will take and it will not take it as 22 by 7. Okay, well, now escape. Again, I will go for declaring to the children what is the volume now. Okay, I will go for the volume. Okay, this volume formula is having a fraction. Therefore, go to the latex formula. In the latex formula, it is 4 by 3 pi r cube. Therefore, 4 by 3. Therefore, A in place of A 4, in place of B 3. Then again multiplication, pi multiplication, pi r cube, radius, radius, the whole cube. Therefore, for the cube, go to the symbol and then come back and here. You see, now this actually gives the idea of the children very clearly, the formula, everything it shows, the whole worksheet shows everything to the children. But a child can understand better. Okay, now let us go for its entry. Therefore, 4 by 3 multiplied by 22 by 7 multiplied by radius. Okay, it is color changed into blue, which means that radius is available, the whole cube. 4 by 3 pi r cube. Okay, that's very simple. Therefore, I think very highly interesting that the child can get the value of it from the formula, and they can understand the formula, they can check the value of volume and all, everything they can check it out. Okay, therefore capital V. Therefore, I got it now. Okay, now I think already I told you one more idea here. That is, suppose if you want to show that volume 523.8 as a fraction also, it is available. For that, it is fraction text of capital V. Just now we had that capital V. You see, it is by 21. I'm so sorry. You should not move it. Fraction text of capital V. Okay. Now you see, I got this number. Here, actually the value of that 523.8 is 111,000 by 21. Suppose you have this radius, when you increase, you see, by 7, by 21, by 21, everything it is going on changing, you see. For a child can understand that also. Anyway, therefore, here what you can do is you can go for this navigation bar. For using the navigation bar, you can tell them that what is a sphere, and you can take the radius, and you can get a sphere, and you can explain them what is surface area, and you can explain them what is the volume, and again you can explain them that volume calculation and so on. And now the child can come and rotate it also. You see, they can come and rotate it. They can visualize that what is the meaning of a sphere, and they can calculate its surface area, and they can calculate its volume also. Thank you. Let us learn to lead.